I never made a audio amplifier with MOSFETs, only with bipolar transistors up until now. And this is my first experiment with MOSFET amplifier, audio amplifier. I went to the website of Jos Verstraeten. He has a very interesting website. It's all Dutch, by the way. He's testing also many say measuring devices, etc., from Ali, with a very critical analysis about how that all works. Anyway, this is his schematic, and I made it also, but I changed it a little bit. I used the first part of his schematic, but I added one extra transistor. I also used another driver transistor, here the BD139, and I used another preamp transistor. So this is what it is at the moment. I want to demonstrate it. So let's look and see what this is all about. So this is the circuit on the breadboard. I have only one important advice. Don't use these very small heat sinks that I've used here. They get very hot, so you need a proper heat sink when you want to make this amplifier. For instance, this one is okay, etc. Another very important thing is that there is one potentiometer that sets the bias of the complete amplifier, and that is this 10K potentiometer. Oops, I will demonstrate it. I turn it now. It goes to 2 ampere. That's far too much, so I must go approximately to 500 milliampere. That is more or less, say, the maximum current that this amplifier can endure, and it's important that it only works on 30 volts. Anyway, I feel the heat, really feel the heat now from these MOSFETs. Very, very hot. Of course you can use a ventilator. I never do that because it's irritating when you want to listen to music, etc., etc. So that was the first demo. I also can smell the transistors. I hope they don't burn out now. Anyway, let's listen first to and look how it amplifies the sine waves. I have switched on the scope. So now you can hear it. It's in the order of, say, 93 Hertz up to 200 Hertz. I think it's approximately 50 Hertz now. I think the amplification is quite okay. Now we go to the next part of the audio spectrum. Have to align my sine wave generator. Again, I have to align the sine wave generator. It has no automatic amplification, and when you know a little bit about how sine wave generators work, that is a serious thing. Anyway, and here we are in the inaudible spectrum. That's, say, all above, say, 80 kilohertz or so. So it worked quite nice. I've tested it over and over, did some adaptations, etc., etc. So let's listen to music now. Well, let me play the copyright-free music. I have to connect the clips, of course. I think it works very nice. And this is the box. So, and I have by purpose used here a 1 kilo ohm potentiometer to keep the input impedance as low as possible, to prevent hum, etc, etc. Could be that you even though need shielded wiring when you use such a low input impedance. Anyway, wanna try to demonstrate the schematic again. Oh, that's wrong. Sorry. I need power supply. So, this is the schematic again. Hope it's visible from this distance. Thanks for watching. This one sets the bias of the end transistors, the two MOSFETs. This one here, 10 kilo ohm, sets the bias of the complete amplifier. And this one here sets the amplification. So these three potentiometers are critical. And of course, when everything works nice at a certain voltage, you can replace them by fixed value resistors. Also has a good bass response. Bend over somewhat. Again, use proper cooling of both the end transistors. You can use two separate cooling plates. And by the way, I've connected two super hi-fi boxes to this amplifier. That's the reason why you hear the sound as it is. Thanks for watching again.